Good afternoon. This is a PowerPoint presentation going over some of the expectations I have for my third year students writing a proper scientific report for biology. It's only a couple marks, and it's not as important as your results in your discussion sections, but I do think we need to spend a little bit more time on our titles. When you're searching for information and you're looking at dozens of journal articles trying to decide which one is the one that you're going to take the time to read, the title is the first thing people see. And often it's the only thing you see for free. In many cases, you'll see the title, the author, and the abstract for free. And then you might have to pay to read the rest of the article. Those titles are what grabs people's attention. And as a published biologist, the number of times that your research gets cited and recited is important. So I don't think we should forget about the importance of a good title that's catchy, comprehensive, and succinct. So it tells everything you need to know about what your paper is about, but it's not too long. Attaching to that, who the author is sometimes can be important. If you find one author that was helpful, you might then search for that same author elsewhere. Sometimes, depending on the journal, the institution that they're affiliated with, a certain university, program, or company is included. And those little pieces of information can be quite helpful and useful. So it's something to start thinking about how you want your name to be presented formally. Not just John Doe. Maybe you want to be JB Doe. Now is the time to start thinking about what your name as a published author is going to be. As I said previously, the abstract is one of the few things that is free for people to look at. Nowadays, we do have a lot of free journals, and we're really lucky at the university. The university subscribes to a lot of journals that we have access to. The abstract needs to summarize the entire report. I might be skimming through abstracts looking for specific information about methodologies. Maybe I'm trying to find a paper that outlines the methodology for salamander care or how to run a transect through a wetland. And I'm not interested in the rest of the report. I just want to figure out my methodology and what I'm going to do for my research. Maybe another time I'm more interested in the conclusions they found or the results they have. Maybe I'm just trying to glean some background information on a topic and the introduction is the part that I'm interested in. All of these things need to be in your abstract so that people can make an informed decision about whether they want to read the rest of your report. I always recommend doing this last, after you've written your entire report. The introduction can be a tricky one. It's basically setting up the stage for the rest of the report. You need to include enough background information so that everyone is on the same page. What is the information your readers need to know in order to understand the rest of your report? So if you're writing a master's thesis, your introduction might be 30 pages long because your professors want you to show all the things that you have learned and all the things that you know. If you're publishing a research paper, your introduction might only be a paragraph or two because you're assuming that if you're publishing in the Journal of Herpetology, that everyone reading this is already going to have a background in herpetology and you just need to define the behavioral characteristics that you're looking at specifically in this paper. So in my classes, we're kind of going to find a middle ground there. I don't expect it to be a super long section, but you do need to give a summary of some of the techniques and reasons and situations that are specific to your report. This is where some of your first citings are going to be. You're going to read some literature to get some background knowledge. You might cite some literature in your introduction. It says here the bulk of your literature cited. That's wrong. The bulk of your literature cited will be in your discussion, but there will be some literature cited in your introduction. The main thing about your methods is they need to be detailed enough that other scientists can reproduce your results. So if you're using a known methodology, you can cite the source of that, or if you're using someone else's methodology, you can cite the source of that. If you're making it up as you go, you need to totally describe your methods. Often people will put subheadings, so have a section for materials as a separate subheading within their methods. Other subheadings I have used in the past is care and maintenance when dealing with animals versus experimental procedure. In my soil science class, you might have your soil assessment as one type of experimental procedure and your plant assessment as another. You also should have your statistical analysis in your methods. If you run any stats, this is where you put it in your methods. You running statistics on your results is part of your methodology. This is where it goes. What formula did you use? What program did you use? For my field courses, we have a study area as a separate section. If you're in a class that everything was done inside, then you might not have study area. And in some papers, study area is a subsection of the methods. But for field ecology of Canada, they typically have study area as a separate section. So this is a situation where you look at the journal you want to publish in and how they format things. Describing your study area is important, again, so people can reproduce your research. What are the things people need to know about your study site so that they can compare it to their study site? For example, if I run a transit line through a wetland and I want to read research that other people have done to compare it to mine, maybe I found that there were a lot of cattails in my wetland and I want to see if that's normal for my kind of wetland. I need to know what kind of wetland I have, and I need to know what kind of wetland other people's research was in. Perhaps knowing the type of wetland, whether it's a marsh or a fen or a bog, perhaps knowing the dominant species, the adjacent forest habitats, if it's close to a city, if it's inside a city limits. We frequently do research in Laurier Woods, which is inside the city limits of North Bay and has a highway and a city yards and a scrap metal yard and a train track all around the edge of the wetland. That has an impact. That's different than a wetland that may be kilometers from any human disturbance. The fact that Laurier Woods has public pathways and regular human traffic also has an effect. If you have the time and effort to talk about the soils present, often that is helpful, but not always. Knowing the latitude and longitude helps. If I've got two papers and one of them is from North Carolina and one of them is from Minnesota, I'm probably going to put more stock in the Minnesota one because its forest is more similar to my forest than the North Carolinian one. This is why we need to know stuff about study area. Most important thing about the results is it's just results. No interpretation, you're just summarizing what you found. The hardest thing that students find here is in first and second year, you're making tables and you're making graphs, and that's all you're handing in. And you're not handing in any written summary of your results. And that's backwards to how you write a written reports results section, where the written section comes first. That's the most important section. And then the tables and figures are amendments to that, addendums, where you're writing out a summary and then you refer to a table when there's just too much data to write out, or you refer to a figure when there's some interesting trend or visual that you want to show. It's important that the tables and figures do not repeat what is in the results. So you can't say we found 15 rabbits and 20 deer and 5 mice, see table 1, and then in table 1 have a table that says you found 15 rabbits and 20 deer and 5 mice. It needs to be more like a summary. Your table should be adding to the data that you present in your written portion. There can be some repetition, but it should be in addition to what you've written down already. If you are including a table, the things to remember is a table caption goes on top, the tables are numbered chronologically, and the caption should be descriptive enough that you do not need to read the rest of the paper to understand what's happening in that table. Other smaller things is if you have a statistical significant data that you should highlight it in some way. Sometimes footnotes are handy. If you have a lot of things in your table and it's looking a bit unwieldy, sometimes adding footnotes can help make it less cluttered. Old school, but I like to line up my decimal points. I'm not going to deduct marks for that. Check the journal that you are publishing in. Only 3 lines in a table. I don't want column lines, just your 3 header and footer lines. Units go in brackets, and any unit that you have in short form in your table, you should describe in your table caption. This is from a website I like. I link it at the end of this PowerPoint. It shows, they call it a table legend, but it shows the table caption. The table caption defines all of the things we need to know. There are column titles that are clear. They use footnotes to help put a lot of information in a smaller amount of space. Figures, basically if it's not a table, it's a figure. Maps are figures, photographs are figures, graphs are figures. Again, you refer to a figure when you can't show something, you want to show a visual, so you refer to a figure. The captions go under the figure. This is different than the tables. Again, they should be standalone. It's nice to include error bars and highlight significance. Remember, if you're making a line graph, don't connect the dots unless they are linear data, where the second dot is reliant on the first dot. I'll explain that more in a second. Axes should be labeled with units, but there should be no title and there should be no grid lines. Nice, clean graph, no grid lines, no title, descriptive figure caption. Here we are connecting the dots because it is germination, cumulative germination. So dot 2 depends on dot 1 because they're cumulatively looking at the percent germination. So they're dependent upon each other. So you're allowed to connect the dots here. The other key thing to point out is there's no color. Traditionally, you never had color in tables and figures or anywhere in a written report because you didn't know if it was going to get photocopied or scanned or faxed. Everything was black and white, and you would choose things that clearly showed what you were trying to show in black and white. This is becoming less common. Some published journals are now starting to include some color depending on the situation, because most things are able to be found in online format. but we are going to stick to the traditional black and white. It's a good habit to get into, and then only using color when there's an extreme situation where color is the best way to show something. But trying to learn and practice black and white is a good skill, so that's what we're going to go with. Again, here is a bar chart instead of a line graph, and you can see the error bars. If one of these 4 error bars was statistically significant, I might put a little asterisk above it and then define what that means in my figure caption. Your discussion is an interpretation of your results. Every result you put in your results section, you need to discuss in your discussion section. Typically, you do them in order, but not necessarily. This also means you don't have to include every single result you found. You can't just leave out the awkward ones, but often we're going through and we just collect a ton of data, and then when you're sitting down, you're going, well, this is really good, but I did this extra step, and that's not helpful to me. So then just talk about the interesting stuff, and you don't always need to include every bit of information. The key thing to think about is here's my result, here's my discussion of why I got that result, and most importantly, here is a cited peer-reviewed journal article that is supporting my claim. So if I say that I have more squirrels in my conifer habitat because squirrels prefer eating conifer buds to deciduous buds, I then need to cite a paper backing me up, supporting this is where I got this information from. And it doesn't have to be exactly, like we're an undergraduate situation here. You might actually find papers that 100% support your claims. Fantastic. But frequently, if you're cutting edge research, when I was doing my salamander behavioral studies, I wasn't citing other salamander behavioral papers always because the research hadn't been done yet. So if you say, I think my salamanders are behaving like this because other researchers found my salamanders behaving like this, great. But sometimes you'd be saying, I think my salamanders behave like this because other researchers have shown that fish behave like this given a similar situation, or birds behave like this given a similar situation. Perhaps my salamanders have that same pattern. You're allowed to stretch beyond the boundaries of what you're working with. Lastly, your literature cited is literally a list of all the literature that you cite in your paper. So every time you put a little bracket with an author and date, you've cited a source. Those sources are in your literature cited. So when I'm reading your paper, I see that, oh, they sourced Jaeger's 1970 paper. I can go to your literature cited, find the full reference for that journal article, and go find it online or at a library. There are different ways to cite this. We often talk about APA and MLA and Chicago are 3 really common ones. I am not super picky which system you use as long as you are consistent. All of your cited pieces of literature need to be done in the same format. All the periods in the same places, all the commas in the same places, all the brackets in the same places. If you're choosing to put brackets around the date, then that has to be in every single case. If you're italicizing the journal title, you do it every single time. Your font shouldn't change halfway through. This happens a lot as you guys copy and paste things. Make sure everything is in the same format. When I say cited, citing is within the text. Rather than write out all the information about that article in the middle of a paragraph, you just do a quick citing. So this can be in several different ways depending on whether you're referencing the name of the author or not, or referencing the year. When there are more than 3 authors, you use et al. It is important, though, that when you actually put the source in the literature cited, that you state all of the authors. The et al. Is only for in-text citations. In your literature cited, you're going to include all the authors. Even if there's 15 of them, you need to write them all out. You do it alphabeticized, lead author first, and then the date. Here I've got examples where I've got them alphabetical: Bachman, Beeler, Boletsky, Bertolino, Bradbury, alphabetical by lead author. If I have two from the same author, then it goes to date. So here I've got Jaeger's 1980 paper prior to Jaeger's 1981 paper. And then where he teamed up with other people, Forrester comes before Jurgitz. And all of his solo publications come before those team publications. So even though the dates, like Jaeger and Jurgitz Jaeger and Jurgitz is 1979, that's the earliest paper, but it comes last because solo efforts first, by date, and then paired efforts or team efforts by alphabet, and then by date. So that's it. Here's the site where I got those table and figure examples. That site also has a lot of other really good advice. Good luck with your report writing.